So welcome to topic 1 of this course. Let's start to code. So the first example problem is hexagonal numbers. So if we click that link on the slides, we can go to the problems on code forces. This is a problem description. So we want to compute the nth hexagonal number. So the nth hexagonal number is defined as 2 times n squared minus n. And if you find this h subscript n confusing, you can ignore that. So this is really just saying we use hn to denote the nth hexagonal number. And we chose h here because it's called hexagonal, so the first letter of that. So what we want is given the input 2, we want to output 6, because if we plug in 2 here, 2n square minus n will give us 6. If we plug in 5, it should give us 45, and so on. So this is the program we need to write. And this is one way to do it. So we have comments here in addition to the actual code. So the file that contains the code is called a source code file, and part of the source code file are for humans to consume. So when we are writing program, mostly they are for computers to execute it, but it's also for other humans who will later need to read the code. Sometimes it's yourself. If you write the code later, you want to read it again, you want to be able to understand the code more easily, so you will use a comment to explain things to humans. So there are two kinds of comments. There are two ways to specify comment. A single line comment will start with this sharp sign, and it will end at the end of the line. So for example, here, this part is a comment. So the computer basically ignore the comment. So it processes the rest of the code. And the second way of expressing comment is using this triple single quote. So a 3 single quote to start the comment, and again using 3 single quote to end the comment. So these comment can span multiple lines when we are using this way. So there are these 2 ways for writing comment, and then the rest of them are code for computers to process. So just to show that there are different ways to do the same thing. So here we give another version of the code, and we're going to explain the element that form this 2 version of the code later, so that we will understand exactly what they are doing. So these are for computer to consume, and you can view them as basically recipe. The computer will read one line and then do what that line tells it to do. So it's do it step by step. And these 2 slightly different recipes, they have more or less the same effect. So given the same input, it will print out the same output. And in part, that's because this is the same as that. It's equivalent to that. 2 times n times n minus n is the same as 2n minus 1 times n. You just apply a distributive law. So let's try to understand the element of these programs. So the first important concept is that of variables. A variable will store value. So you can think of it as a container. So a box, even a cup, whatever that's convenient for you. It's a container that, and what it stores is the values. And the container needs to have a name, so that because we'll be using multiple containers, we'll be using multiple variables. So we need to be able to refer to the one we really want to use. So they need to have a name. And the name of a variable must start with either a letter or the underscore character, which looks like this. And it's followed by letters, digit, or underscore character. For example, this is a fine name for a variable. And we allow underscore. One major reason is we can use a word to make the name meaningful, and we can use underscore to separate them. otherwise it's just a bunch of letters together. It's more difficult to parse visually. And here the things that are highlighted are the variables in the program. Okay, and literals are constant, are values, or in the case that dealing with numbers, they're just numbers. So in this code, the literals are this 1 and 2. So this 1 and 2 are literals. They represent a value, and each value will have associated type. Here, 1 and 2 are of the type int, which stands for integers. So later we're going to see a string literal. So each literal represents a string. It's just a string of text. So computers can compute, and when we compute, we use operators. There are many different kinds of operators. Here, the first ones we are going to introduce are arithmetic operators, which you should be familiar with. So it's addition, subtraction, multiplication, and division. And there are other arithmetic operators that we will introduce. A few more will be introduced in this topic, and other operators will be introduced later. So I think these should be pretty familiar. This is the same kind of operator you use in math that you've learned.